So my iPad is not working today, and so I'm going to go for a low-tech video here. We've got my phone balanced on top of a meter stick, but hopefully this works okay. So our video today is about naming type 1 ionic compounds. First, you'll see this term IUPAC. That stands for the International Union of Pure and Applied Chemistry, and there's an IUPAC naming system, which is just an internationally agreed upon way to name compounds. So it means that no matter where you are in the world, you can talk about sodium nitride and people know what you're talking about. Speaking of which, let's just do a quick practice with how do we make ionic bonds. So let's say you're mixing nitrogen and sodium. We want to find out the resulting ionic compound. So first what we do is we look those guys up on our periodic table. I've got sodium is right here. Sodium's in group 1, so that means it has a charge of 1. So I'll write down the sodium has a charge of 1, and it's going to want to make a positive 1 charge. It's a cation because it wants to lose that single valence electron that it has in group 1. Nitrogen is way over here. Nitrogen's in group 15. That means it has 5 valence electrons, so it wants to gain 3 more in order to have a full valence shell with 8. So nitrogen wants to have a charge of -3. So how do I figure out how these will bond? Well, I can swap the charges to know how many of each I get. I'll have 3 sodiums with 1 nitrogen. So the chemical formula will be sodium 3 and then 1 nitrogen. Now how we'll name that, we're going to find out in a minute, is sodium nitride. And I'll show you why that works out in a minute. All right, so there's actually 2 kinds of ionic compounds that we can do. Type 1 ionic compounds are going to be just in a metal like in group 1 or group 2 that has just 1 cation or charge. So this would be somebody like sodium or magnesium. There's only 1 charge that they can form. That'll be type 1 compounds. In our next video, we'll look at type 2 compounds. So those are mostly those transition metals that can have multiple charges. So when we try and make ionic bonds with them, it's a little bit more complicated. We need 1 extra step to our naming. But first, we're going to start with the simplest ionic compounds. So these are the guys that only have 1 charge they can form, the type 1 ionic compounds. Here's what you do. First, you write the cation. So the cation, that's the metal first, and then you write the anion second. That's going to be the nonmetal. So metal first, the nonmetal, the anion second. Then you just write down the simple name of the cation. So whatever your metal is, you just write it down. So just like we did here, we had sodium was our metal, so we just literally write down the name sodium. So we'll write the name of the metal. Next, we write the anion or the nonmetal. But here's where it changes a little bit. We're going to change the ending to "ide." So instead of writing the regular ending of our nonmetal, we change it to IDE or "ide." Let's see what that looks like in a few examples. So starting with sodium chloride here, a table salt. So we see the Na, that means sodium. The chlorine, we just changed the ending of chlorine. So I write sodium. The metal, I write the full name. So this is the metal. I'll just write underneath what I've got here. That's the metal. Then I'm going to write the non-metal, but I'm going to change the ending to "ide." So sodium chloride. So instead of writing chlorine, I write chloride. All right, next one, I've got calcium is my metal. So the metal is calcium. Then next I'm going to write the nonmetal. Now this is where sometimes people get tripped up. They see that this is calcium with 2 bromines here. So you might think, oh, do I need to say something about the fact there's 2 bromines? You don't, because that 2 bromines came from the charges, right? Calcium, everyone knows, has a charge of 2. Well, not everyone. Everyone who has a periodic table knows this because you can find calcium in group 2. Calcium always has a charge of 2. And bromine always has a charge of -1 because it's over here in group 17. It has 7 valence electrons. So bromine must have a charge of -1. So if I swap the charges there in order to figure out how many of each I have, I must have 1 calcium and 2 bromines. It's got to be that way, right? That comes from the charges. So I don't need to indicate in the name that there's 2 bromines. We know there has to be 2 bromines because of the charge. So all I have to write here is I make the ending of bromine-ide, and then I just write the first half of the word. So I write bromide instead of bromine. And my compound here will be calcium bromide. That 2 bromines there is accounted for through the charges. And the last example here, the metal, Al, that's aluminum. And the non-metal, that's oxygen. And again, we have to change the ending to ide. So oxygen, when we change that ending, it becomes oxide. So we write oxide like that. And that compound there is aluminum oxide. Once again, I don't have to worry about the fact there's 2 aluminums, 3 oxygens. That came from the charges. The charge of aluminum is 3, the charge of oxygen is -2, and that's why there's 2 aluminums and 3 oxygens. So I don't need to account for that in the name, it's given by the charges already. And that's how you name type 1 ionic compounds.